In Module 1, you learned that the speed of a sailboat is dependent upon an unusual variable, the length of the boat. But how does expressing the algebraic relationship between hull speed and boat length actually help the boat designer? And how can expressing relationships between variables also help make a modern sewage plant run more efficiently? In this module, you'll learn that an important attribute of the relationship between two variables appears as the rate in the table, the steepness of the graph, a number in the symbolic form. Beside the shores and under the waves, contamination from sewage takes its toll on our nation's water. And without a plentiful and healthful supply of nature's elixir, life would be forever changed. In building sewage treatment plants like this, we have taken steps to ensure our future.
A modern sewage treatment plant is a maze of pipes, pumps, valves, and tanks. This plant outside of Los Angeles handles about 60 million gallons of raw sewage every day. Because the volume of sewage varies from day to day and from hour to hour, the flow through the tanks and basins must be constantly adjusted by opening and closing valves.
The flow of sewage through these pipes is an important factor in the efficient operation of this facility. Those who design sewage treatment facilities and those who run them use algebra to do their work. Let's examine what happens when a pipe begins to fill a tank that already contains 50 gallons of sludge. By looking at any two consecutive entries in the table, we can see that every 5 seconds, 10 gallons are added to the tank. No matter which pair of entries we pick, dividing the number of gallons that have been added to the tank, 10, by the amount of time it took to add that many gallons, 5 seconds, gives us the rate at which the pipe is filling the tank, which is 2 gallons per second. We've seen how the rate can be found in a table. Now, how is that aspect of the relationship expressed in the graph? The increase of 5 seconds in time appears in the graph as a horizontal distance. The increase of 10 gallons is a vertical distance. Because the rate is the same for every pair in the table, the points lie along a straight line. If the rate of flow is increased, the linear pattern will be steeper. If the rate of flow is decreased, the linear pattern will be less steep. The rate of flow that we determine from the table is directly connected to the steepness of the graph's linear pattern. Finally, let's look at the rate's impact on the symbolic form. The number of gallons that have been added to the tank is twice the number of seconds since the pipe opened. Thus, the equation is G equals 50 plus 2 times S. 2 gallons per second, the rate at which the pipe is filling the tank, can be calculated from the numerical values in the table. It also determines the steepness of the graph's linear pattern, and it also appears in the term containing the input variable in the symbolic form. Let's examine the linear relationship between boat length and hull speed by first looking at a graph. Use the horizontal axis to represent the boat's length in feet, and the vertical axis for speed in knots. That's a nautical term for miles per hour. Any combination of length and speed can be represented on this graph. For example, a 24-foot sailboat has the hull speed of 6.7 knots, while the speed of a 60-foot racer is 10.3 knots. Using just 2 points, a line can be drawn that shows the hull speed relationship, so that you can get an idea of the speed for any length of sailboat. But we can obtain better predictions if we find a symbolic form that describes the relationship between boat length and hull speed. Here's a table showing the 2 pairs that we know. Even though there are only 2 pairs, we can find the rate at which the boat speed increases. The hull speed increases by 3.6 knots when the boat length increases by 36 feet. In other words, the boat designer can increase the hull speed by 0.1 knots for every foot he increases the length. We could use this rate to build a larger table. However, the symbolic form is a more valuable tool to the boat builder. Moreover, we already know the rate, and we also know that the rate plays a major role in the symbolic form. It appears in the term containing the length. It's not hard to find the missing term, because we know two pairs that are part of the relationship. Let's use one of them. A 24-foot boat can achieve a hull speed of 6.7 knots. We need to add 4.3 to 2.4 to get 6.7. Notice that if we used 60 and 10.3, we reach the same conclusion. We now have the complete symbolic form of the relationship between hull speed and boat length. The symbolic form is as important a tool in designing a boat as hammers and nails are in building it. In this module, you've learned that an important attribute of a relationship between two variables appears as the rate in the table, the steepness of the graph, a number in the symbolic form.